Foundational Mathematics Year 2. This is your instructor and facilitator, Mr. Alfred Gordon. In today's lesson, we shall be looking at these outcomes. Establish Demorgans' law of set theories and use them to solve related problems. Describe set theories as a foundation for many subfields of mathematics. Create and model set problems in areas pertaining to industry, commerce, and sports, and apply laws of set theories to real-life situations. Our learning indicators: by the end of this week, we will be able to establish Demorgans' law of set theories and use them to solve related problems. Describe set theories as a foundation for many subfields of mathematics. Create and model set problems in areas pertaining to industry, commerce, sports, etc. Content standards: demonstrate the ability to use properties and theories to solve real-life problems and apply binomial theorem to approximate numbers to a given index. The strand is modeling with algebra, and the substrand is application of algebra. Before we begin the lesson, let us first look at some set notations that we shall see. Some set theories we shall see in this. Some set notations we shall see in this lesson. They say the definition of set. A set is a collection of well-defined objects. Yes. So, collection of well-defined objects, like the set of fruits. Okay. A set of natural numbers, set of whole numbers. Okay. Also, the universal set, which is denoted by big U or mu, that is a set that contains all elements under consideration. We shall also consider the complement of a set. So for a set E, okay, its complement is A prime. Okay, all elements in U, but not in A. Now the union of two sets, that is for set A and B, it's all elements in A or B or both. Okay, so we're looking at the combination, combining the set A and B without repetition of elements. Now intersection A, intersection B has to do with all elements in both A and B. Okay, so elements that are in A and also in B. Now let us look at a Venn diagram to represent this information. Okay, so let's do away with this, and then let's have a Venn diagram situated here. Okay, so stay with me. Okay, so let's have this as a two-set Venn diagram. Okay, with set A and then a B and then a universal set. Okay, so what you find here is that the region, okay, the region shaded in red, okay, represent the region that is only in what? In A. So that's the region that is in A, but not in what? B. That is A only. However, the region shaded with green, okay, also has to do with elements that are in A and also in B. And the region that is shaded in the yellow ink, okay, also has to do with the elements that are not in A but are in B. However, the region outside of this two circles will represent the region outside the two circles will represent A union B, okay, complement, which is the same as A complement. So not in A and not in B. Good. Now some key properties. For a set A, okay, A union its complement gives us U. Let's find out. So let's consider U to be a set with element 1, 2, 3, 4, 5. And let the set A be a set with element 1, 3. Then we can say that A complement, that is element in the universal set but not in A. So let's find out. So 2 is in the universal set, okay, it's not in A, so 2. 4 is in the universal set, not in A, okay, so 4. 5 is in the universal set, not in A, okay, so 5. Now, however, when we find A union A complement, we are getting 1, 3, 1, 2, 3, 4, and 5, which is same as the universal set U. Okay, so this is true. Now also A intersection A complement. So looking at A and A complement, we could find that there are no elements that are common, okay? So that gives us empty set, which is same as phi. Okay, phi. Okay. Then we have A complement, which has to do with the complement of the complement. So this is the complement, and the complement of this complement, that means element in the universal set, not in A complement. We have 1, and then we have a 3, which is equal to the set A. Okay, so A complement gives us the set element A. Okay, now focal area 1. Establish Demorgans law. The objective for this focal area is to understand and establish Demorgans law through algebraic and graphical methods. Key questions. Okay, how do complements relate to unions and intersections? Now, we learned in year 1 that how to identify regions in the 3-set Venn diagram. Now, we apply this to solve real-life problems. Okay, so let's find out. This is the 3-set Venn diagram, and let's try and then identify these regions of the 3-set Venn diagram. So for this Venn diagram, let U be the universal set, okay, and then let set A, that be set B, and that be set C. Then we can see that this region, let me number the regions, I, V, okay, and then the region outside of the 3 circles, okay, I. So the set A, the set I, okay, the region I has to do with element in A, okay, sorry, element in A, not in B, and not in C. That is A only. I has to do with elements that are in A, they are in B, but they are not in C. So if you find a region, it's just this portion. This whole region here has to do with A intersection B, but C is out. Okay, now the third region has to do with elements not in A, but they are in B and not also in C. That's for B only. The set that the region IV has to do with elements in A, they are in B and also in C. V has to do with elements in A, not in B, but also in C. VI, that is elements not in A, okay, they are in B and in C. And VII, that is elements not in A, not in B, VIII, that is A union B union C, all complement, okay? Or elements not in A, not in B, and not in what? C. Now we shall classify this as one of the Demorgans law. Okay, so Demorgans law. Okay. Okay. So I shall pause this video here and then continue this lesson in the next video. Thank you.